Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 611, valid triangle number. So given an integer array nums, return the number of triplets chosen from the array that can be make triangles if we take them as side lengths of a triangle. Okay, in fact, they are asking us to find how many number of triangles we can make with the numbers given in the array. Okay, and we want to return that numbers. Fine. So see here, if the array is 2 comma 2 comma 3 comma 4, then I can tell you we can make 3 triangles. So what are them? So take this first 2 and then 3 4, take this second 2 and 3 4, and take 2 2 3. So here you want to know about the conditions of a triangle, right? So to form a triangle, I want a condition like two sides, any two sides like a plus b should be greater than c. Okay, and also c plus b should be greater than a, and also c plus a should be greater than b. So if these three conditions are satisfied, then I can tell you that the triangle is a valid triangle. If any one of this condition is not true, then I can tell you that it is a invalid triangle length. Can you understand this? So this is the condition you want to know about. Fine. So that's the reason why you have taken these values. For example, see here, if I take 2 2 and 3, sorry, if I take 2 2 and 4, which means 4 plus 2 is greater than 2. Okay, but 2 plus 2 is not greater than 4, right? It is equal to 4. It is equal to 4, not strictly greater than 4. So because of this condition, we cannot take this length as a triangle. Can you understand now why we cannot take 2 2 4, right? So this is the reason why they have given the output as 3. There are only 3 possible triangles we can make from this combination, and from this combination we can make 4 triangles. Fine. So what is going to be the basic brute force approach? So what is the brute force approach? So the brute force approach is, I want to just go and find all the combinations, okay, and check whether the combinations, whichever combinations follows this rule, then those combinations will be counted in my result. Can you understand this? So for example, first of all, I will be taking a pointer here and a pointer here. Now I will be taking this 3 in my first try, which means 2 comma 2 comma 3, whether it is a valid triangle, yes, then take this as result as 1 now. Okay, now take this 4, whether 2 comma 2 comma 4 is a valid, no, so I cannot take it in a result. Okay, now place this pointer to here. Okay, now 2 comma 3 comma, only thing is 4 remaining, right? 4. So whether this is a valid triangle, so just check 2 comma 3 comma 4 is a valid triangle, yes, right? So in this case I'll be making this as 2. Now move this pointer to here. Okay, and this pointer will be here and this pointer will be here, which means we are just making 3 loops. Inside those 3 loops we are going to put this condition. Okay, that's going to the brute force approach. Now this 2 comma 3 comma 4 is also valid, so now make this as 3, that's it. So this is going to be the result. Now tell me what is going to be the time complexity. So time complexity will be O of n cube, meanwhile the space complexity will be O of 1, so it is not a big deal. Okay, the brute force approach is not a big deal. Fine. So how we are going to optimize this? So that's the second thing, right? Because O of n cube is way higher, and also how to find whether it is a higher or lower. So see here they have given that it is 1000, which means n cube will design me like 10 power 3 the whole power 3, which is equal to 10 power 9. The clock time that accept is 10 power 9, so it will be failing for this particular time complexity. So that's the reason why we want to optimize it like either like n square log n or n square, or below this n square log n. We want to give the time complexity which is below the n square log n. So how we are going to do that? So that's going to be the next part, right? So let me take this array so that there are many number of elements and we can just understand how we are going to implement it. So what are 3 conditions we want to follow? So these are the 3 conditions we need to follow. Okay, so if I sorted the array. If I sorted the array, then it will be easy for me to get what are all the larger value and what are all the smaller value, right? Can you understand this? Why I am going to sorting, right? Because in this scenario, we need what is the larger value, okay? And I'll be only comparing that larger value alone, okay? And I can use the 2-pointer approach. Okay, so whenever you are solving more number of 2-pointers question, then you can able to solve this question also. Okay, then you can understand why we are going with the sorting technique. Fine. So first of all, sort this array. So if I sort this array, it will be like 2, 3, 4, 4, 5, 6, 7. As of now, just listen to this so that you can understand what the logic I am going to use. Okay, fine. Fine. Now after sorting this, place a pointer here. Okay, let me write the index 1, 0, 1, 2, 3, 4, 5, 6. So place the index at the last place the pointer at the last index. Okay, then place next to 2 pointers right here. So here one pointer, here one pointer. Okay, now if I ask you what is the sides of the triangle hats of now, then you will be telling me 2, 6, 7 is my triangle. Length. Correct. So here, whether I want to check for these all conditions, no, because I can tell you that the larger value here is the 7. Larger value is 7. However, we want to only check whether the 0th index element plus the 5th index element is strictly greater than the 6th index element. Then if this one and only condition satisfied, then I can go further and take all the elements right there, right? Can you understand this? See here, this 7 is the larger value. If I put 7 plus 6, it will be absolutely greater than 2. If I put 7 plus 2, it will be absolutely greater than 6. Then why should I check for these conditions? I will be checking for only one condition called whether 2 plus 6 is greater than 7 or not. Can you understand this? Yes. If it is greater, then what is going to be the next step? So see here, if this is greater, right? Because it yields 8. 8 is greater than 7. So this implies that all the elements between can also form a triangle, which means 3 plus 6 will be absolutely greater than 7. Similarly, 4 plus 6 absolutely greater than 7. Meanwhile, 5 plus 6 absolutely greater than 7. So from here, what I am going to do in the next step, it is a very easy step. So see here, initially the result is going to be 0 initially. Now what I am going to do is just to make this pointer to the first step is, what is this pointer's value? It is 5. It is in the 5th index. What is this pointer value? It is in the 0th index. So I can tell you that we can form 5 minus 0 combinations, because I can take this 2, 6, 7, then 3, 6, 7, then 4, 6, 7, again this 4, 6, 7, again this 5, 6, 7. So there are totally of 5 different combinations we can come up with, right? So that's the reason why I'm doing what? 5 minus 0, which means plus 5. Can you understand this? And then make this pointer value to move here. Can you understand this? Yes. Now what is the next step I am going to do? Now again check whether 2 plus 5 is strictly greater than 7. No, 7 is not greater than 7. In this case, what I am going to do is, I will be making this pointer to move one step ahead, so that I will be having a value which is greater than the 7, right? I may get the value greater than 7. See here, 3 plus 5 is strictly greater than 7. 8 is greater than 7. So from here, what I am going to do, 4 minus 1, which is equal to 3. So there are 3 possible combinations I can get. So 5 plus 3, which is equal to 8. 8 is as of now the result. And make this pointer to shrink. And understand this, the algorithm? Yes. Now, what is the next step? Whether 3 plus 4 is greater than 7, strictly greater than 7? No. So what you are going to do? Move my lower limit pointer to plus 1. Now 4 plus 4, whether it is greater than 7? Yes, Yes, at this particular point, what you are going to do? Just take 3 minus 2. 3 minus 2, which is equal to what? 1. So plus 1, which is equal to 9. Okay. Now, what we are going to do? Make the right pointer to minus 1, which means just reduce the right pointer by 1. Now, it is these two pointers are at the same index. So here I should stop and make this iteration to minus 1, which means, let me take the again. So this is for 7, right? Now I'll be shrinking and making my yellow pointer to come here. Again, I'll be making my right pointer here and left pointer here, and repeat that process, that same process. Like, see here, 2 plus 5 is strictly greater than 6, right? So which means I can say, let me put the index value 0, 1, 2, 3, 4, 5, 6. Okay. Now I can clearly state here like 7 is greater than 6, strictly greater than 6. Then I can say 4 minus 0 is added to my result. So which is equal to 4, which means 13 is added to my result. Yes, because if 2 can make, then absolutely 3 can also make, 4 can also make, again this 4 can also make, so it will be 13. Okay, after this I will be going quick, little quick. Okay, now what I am going to do, I will be making my right pointer to move here. Now again, whether 2 plus 4 is strictly greater than 6, no. At this point, what should I do? I will be making my left pointer to move ahead. Now whether 3 plus 4 is strictly greater than 6, yes, at this point what will we do? 3 minus 1, which is equal to 2. So add 2 here, 15. Okay, and make my right pointer to move one step behind. Okay, now 3 plus 4, again whether it is greater than 6, yes, it is also greater than 6. Then from here I can tell you what, I will be taking 2 minus 1, which is equal to 1. So take 1 here. Yes, can you understand this? Okay, fine. Now what is the next step I am going to do? I will be making this right pointer to move one step behind. Now these two pointers are at the particularly one index. Okay, now what I am going to do, string the yellow pointer. So let me continue here, string the yellow pointer. So yellow pointer will be now at this particular point. Okay, 0, 1, 2, 3, 4, 5 and 6. Okay, now here is one orange pointer and here is one orange pointer, left and right pointer. Now whether 2 plus 4 is strictly greater than 5, yes, it is strictly greater than 5. Then I can put here like 3 minus 0 will be added to the result, which is equal to 3, which means 16 plus 3, which is equal to 19. And I'll be making my right pointer to move one step behind. Okay, now again whether 2 plus 4 is strictly greater than 5, yes, at this particular point what will I do? I'll be just taking 2 minus 0 and adding to the result, which means 21, right? And make the right pointer to move here. Now whether 2 plus 3 is strictly greater than 5, no. At this case what will you do? You'll be making this left pointer to move one step ahead. Now these two pointers are at the same index, so I will be doing what? I'll be just moving my yellow pointer one step behind. So in next iteration it will be like, let me write here, in next iteration the yellow pointer will be standing here, one of the orange pointer will be standing here and another one is standing here. Okay, let me change the color, 0, 1, 2, 3, 4, 5, 6. Okay, now tell me again, 2 plus 4 is strictly greater than 4, which means what should I add? 2 minus 0 should be added, so which is equal to 2. So here it comes 23, and I'll be making my orange pointer, this right pointer, to move one step behind. Now whether 2 plus 3 is strictly greater than 4, yes, absolutely. So what I am going to do, I'll be changing this as 1 minus 0 is equal to 1, so 1 is added to here, so it is 24. Okay, fine. Now after adding it, what I am going to do, I'll be making this right pointer to move one step behind, and these two pointers are facing each other at the same index. So what I am going to do next, I'll be shrinking my yellow pointer. So if I shrink my yellow pointer, it will be like, it will come here, 0, 1, 2. Okay, now where is my orange pointer? One is here, another one is here. Now whether 2 plus 3 is strictly greater than 4, yes, which means what I am going to do, I'll be just subtracting these two things and adding here. So it will be 25, and I'll be making my right pointer to move one step behind. So 2 pointers are at the particular same index. So stop here, and should I make this yellow pointer to come here? No. If I make this yellow pointer to come to this index number 1, then I don't have 2 indices before it. So stop here. What is my final answer? It is 25. Can you understand this? Okay. So this is what the entire approach. So what is the time complexity? It is going to be O of n square. And what is space complexity? It is O of 1. Okay. If you sort it using the selection sort or bubble sort or insert sort like that. Initially we are sorting this, right? If you are using the merge sort, then the time complexity will be O of n log n plus n square, because here we are traversing 2 times, right? We are traversing 2 times for each and every elements. Like for n elements, we are traversing n times. So n into n, which is equal to n square. That's the reason why we are getting here as n square. And what is the space complexity? It will be O of n if I use a merge sort algorithm. So rather use this selection sort for sorting, so that it will be not taking the space complexity. Fine. So let us get into the code. See here I am using a Java code. If you want the Python or C++ code, go and find in the description. Okay. So see here I first of all sorting the array, then count is equal to 0 initially, n is equal to num's length. Now I will be starting I is equal to n minus 1, the last index, and I is greater than or equal to 2, and I minus. Okay. Now left is equal to 0 and right is going to be I minus 1, as I already said in the drawing explanation. Now while left is strictly less than right, okay, then what should I do? I will be first checking whether nums of left plus nums of right is strictly greater than nums of I. So this is the triangle condition. Okay. If it is so, what I am going to do? Count plus is equal to right minus left, and do right minus. Okay, I will be shifting my right pointer to its front index. Okay, else I will be shifting my left pointer to forward, because it may lead to this particular condition, because it is in a sorted order, right? That's the reason why I am doing this. Now at last I will be returning the count. That's it. Let me submit this. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And if you have some doubts, just comment below. I'll be commenting out the answers. Thank you.